Is it right? Students, A cross B is given. Cartesian product of A and B. They given all order pairs. They're asking what is A, what is B. What about the first non-empty set here? A, capital A. So what are the first components? What is the first component here?
A and B.
A and B. So that A comma B. So capital A is equal to A comma B. The set of all first components, which is belongs to A, right? So what about B? Capital B.
X comma Y.
X comma.
So here, actually, we know that the Cartesian product of A cross B. How can we write the Cartesian product A comma B such that the first component which is belongs to capital A and second component which is belongs to capital B. The set of all first component which is belongs to capital G and the set of all first second component which is belongs to capital B. The same way here, the first components are A, B, second. See, we'll write directly itself. Okay, fine. Next. Is it clear the question number 6? Let's go for the question number 7. What they're asking here, A is equal to 1 comma 2, B is equal to 1, 2, 3, 4, C is equal to 5, 6. So A, B, C, D are 4 non-empty set they given. Verify that A cross B intersection C is equal to A cross B intersection A cross C or not. Look at here. These are the properties. We have to verify the property. What is the first property is given? A cross B intersection C is clearly equal to A cross B. What is the symbol here? Intersection. Intersection A cross C. Don't take union. Intersection becomes intersectional. In the same way, A cross B union C should be equal to A cross B union A cross C. Let us check now. Yeah, first question. All of you tell me what is B intersection C? Common element to B and C.
Null.
Null. Okay. So here there is no common element. The first question is that first subdivision is A cross B intersection C is clearly equal to whether A cross B intersection B cross A or not. So before that, B intersection C, I want to find there is no common elements, that is empty, that is null set. Whenever it is null set, A cross null set becomes what? Null. Am I right?
Yes, sir.
Okay, this. So LHS value becomes A cross B intersection C is clearly equal to null set. Then what about RHS? To find RHS, first you have to find
Again,
A
it's
cross.
null, sir.
What is A cross B first? A cross B. First, you should write all the order pairs which is belongs to A and B, right? 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, right? The possible order pairs are 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4. Then 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4. You should write the order pairs first. In the same way, A cross C. What are the order pairs A cross C? 1 comma 5, 1 comma 6, 2 comma 5, 2 comma 6. Is it clear, students? See, A cross C is given by 1 comma 5, 1 comma 6, 2 comma 5, 2 comma 6. These are the possible order pairs. I have written everything. Now we need to find intersection, the common order pairs. A cross B intersection A cross C is equal to what? Anyone?
The null set.
Null set.
Is there any common element? No,
No,
null
sir.
set. So LHS equal to RHS. Okay. Clearly LHS equal to RHS. So what we verified, it will be equal. First one is okay. We verified that it is equal. Now here the second one is A cross C is a subset of B cross B? All of you, first you should find the set of order pairs of A cross C. Then you should find B cross D value. Yes, everyone, is that right? Is A cross C subset of B cross D or not?
Yes, sir.
Fine. Let's see here. What is A cross C elements? A cross C.
So instead of finding individual things like this, we can also find in the way like if A is the subset of B and even C is a subset of D, and so it will be.
No, sometimes it might be wrong. You're saying that A is subset of B.
And C for D, sir.
Yeah, C for because first component.
Yes, sir.
Yeah, we can check it like this also. So whenever the empty set is involving at the time, okay, but okay, almost first set we have to check whether it is subset to B or not. Second, C is subset to B or not. Both will be satisfied. We can say that A cross C also subset to B cross C.
Sir, then it is satisfying, sir, so it is answered.
Yeah, but no, in in OBT wise we can say directly, okay, it is subset to B, C subset. We can say directly it is a subset. But NCRT, you should write the steps. That's it.
Okay.
Yes, it is a subset. Very good. All of you find A cross C and B cross D and check it. It is true. Right. See, question number 8. A is given, B is given. Write A cross B. Oh my God. See, A cross B will write. Okay, fine. How many subset will A cross B have? How many subset?
16, sir.
16. List them.
2 power 4.
Yeah, 2 power 4. You have to write all 16 subsets.
The subset means relations only, no, sir, here.
Relations. I told you, every relation is a subset to the Cartesian product. Every subset is a relation. We can call a subset of A cross B, or else that subset is called relations, right? See here, 1, 2, 3, 4.
Sir, we should write all the 16 things, sir.
All the 16. What the question itself they ask, you have to list all the subsets. List them, right? Okay, fine. Here, given that all of you write fast. Then A cross B is clearly equal to 1 cross. Two, 1 comma 3, 1 comma 4, 2 comma 3, 2 comma 4. This is card. Since here, for example, you can take any set. For example, I'm taking AB already we have taken. Capital P is any set, and N of P is equal to, okay, power set we can take, not capital P. Okay, simply you can take like C. Capital C is any set having n elements and some k elements. Number of elements in capital C is equal to k, which implies the number of subsets means the subsets are given by power set of C. P of C is here number of the set of all subsets. So the number of power set which is belongs to C is given by 2 power k. Nothing but here also same. The number of subset of A cross B is given by
2 power A into B.
exactly. So
2 power N of
n of P of A cross B is clearly equal to 2 to the power of N of A into N of. I'm telling the steps to write in NCERT. So here 2 into 2 that is equal to 2 power 4 that is equal to 16. Okay. Now we will write all the subsets. Okay. So anyhow, we are having
Sir,
16 subsets.
sir, one doubt, sir. If we change the order, then it's again a subset, no, sir.
Yeah, subset, surely. Order is not important. See, 1, 2, 3, 4. You may write 4, 3, 2, 1. You should not write like 1, 2, 3, 4, 4, 4, 3, 2, 1. Same only.
Yes, sir.
Okay, you should not write. Right, I'm going to write the number of subsets. Shall we start? So what are the subsets? The subsets I'm going to write here. First, empty. Next, is.
Sir, 1, comma 3.
Subset means you should write every subset in curly bracket. 1 comma 3 curly bracket. Curly bracket of 1 comma 4. Curly bracket of 2 comma 3. Curly bracket of 2 comma 4. Okay, these are the given order pairs. Next,
Sir, 1, comma 3, comma 1, comma 4.
okay, 1 comma 4. Then
1, comma 4, comma 2, comma 3.
okay, first we will take 2 comma 3 comma 2 comma 4. Then as you said, you can take 1 comma 3 comma 2 comma 3.
Sir, then 1, comma 4, comma 2, comma 4.
Okay, fine. 1 comma 3 comma 2 comma 4. Then next 1
1,
comma
4, comma
4
2,
2 comma.
4, sir.
So what about 1 comma 4 comma 2 comma 3?
Okay, sir.
If you write like in order wise like this, we may not be repeat that. If we writing like okay zigzag like okay 1 comma 4 2 comma 3 like that, we might be again repeat 2 comma 4. Next, okay, first I'm taking null set, then after I've taken the single order pair, next I have taken two order pairs, next we will take three order pairs like 1 comma 3 1 comma 4 2 comma 3. Is it okay? Right, next 1 comma 3 1 comma 4, then 2 comma 4. Is it clear? Is it clear? Then any other possibility? Three order pairs? Anyone? 1 comma 3, then 2 comma 3, 2 comma 4. Is it right? 1 comma 4, 2 comma 3, 2 comma 4. We can write very easily, right? No doubt. First null set, then a single order pairs, and two order pairs, then three different order pairs. Any other three order pairs is possible. That's it. Till now, how many? Yes, students. How many order pairs we have written till now? 1.
15, sir.
15, sir.
The last one is what?
Sir, A.
All the four.
All 4. 6, 7, 8, 9, 10, 11, 13, 14, 15. Right. Right. These are the 15. Finally, we have to write 1 comma 3, 2 comma 3, 1 comma 4, 2 comma 4. Right. Is it clear, student? Simple. First, and I have written single order pair, then 2, 3, finally 4. These are the required 16 subset of given cross product A cross B.
Sir, 1 minute, sir.
Yeah. Those who have completed this question can go for the next one. Can try to do the next question. Total, how many questions are given in this exercise?
10, sir.
Okay, right. You can try the next one if you completed this. Clear?
Yes, sir.
Let's go for the next question. Yeah, next question. Is it difficult? The next one. Let A and B be two sets such that n of A is okay. Number of elements in A is 3. Number of elements in B is 2. If x comma 1, y comma 2, z comma 1 are in A class. Find here. Yes, students.
Sir,
A
A
and B.
equal to x comma y comma z, and for B it's 1 comma 2.
Simple. That's it. Understood? A cross B they given. So the elements which is belongs to A cross B clearly they given, like x comma 1 and y comma 2 and z comma 1. So if you observe here, see the first component which is belongs to A. So A is equal to, what are the first component? X, Y, Z. So easier, these components are correct. How many components we got here? 3. But see here, in the question itself, they given n of a is equal to 3. Yeah, absolutely right. Clearly, they said they given 3. So a is equal to x, y, z. Then the second elements is given by, the second components are given by the set B. What are the second components here?
1, comma 2.
1, comma 2. That's it. Find A and B. Okay, we found A value is x, y, z, then B value is 1, comma 2. Where x, y, z are distinct elements. Sure, whenever it is distinct element, then only n of A becomes 3. For example, any two of them are equal. Can we write n of A is equal to 3? No. X, Y, Z are distinct elements, then only n of A value is 3. Okay, this is the right answer. Okay. A cross B is equal to this. A is equal to set of all first elements, B is set of all second elements. That's it. That is the answer. The 10th question, the Cartesian product of A cross A has 9 elements, among which are found -1, comma 0 and 0, comma 1.
Sir, they are given all the 3 elements, sir.
Find the set A and the
Set A is
remaining.
-1, comma 0, comma 1.
Okay. Here the question is that A cross A has 9 elements. A cross A has 9 elements means A cross A has 9 elements. Means A cross A means shall we write like this? N of A cross A is N of A into N of A is equal to 9. Shall we write? So N of A, the whole square, is equal to 9. 9 nothing but 3 square. Then N of A value must be equal to 3. Okay. So A having 3 elements here. So this is one of the important question. The question that was the same. N of A cross A 9. N of A, the whole square is equal to 9. Number of elements in A is 3. We found that A having 3 elements. Then what are the 3 elements? Can you tell me your, okay, in that they given 2 order pairs. A cross A having 9, in that they given 2. That is, what are the 2? -1, comma 0. Another order pair is 0, comma 1. Then remaining how many order pairs we need to write? 7 order pairs. Okay. To get that, first we have to write the set capital A. Okay, capital A consists already 3 elements. What are the 3 elements? Students, what do you observe in these two given 2 order pairs? What are the elements you observe here? Yes?
-1, 0, and 1 in
Yes,
common.
-1, 0, 1. Very good. A having 3 elements means 3 elements are distinct here. Okay, that is -1, comma 0, comma 1 from the given order pairs. Okay, so we return, they already given 2. We need to write remaining 7 order pairs. Okay, totally 9. Okay, what are the remaining 7? Can you anyone?
So
See here.
-1, 1.
-1, 0, 1. -1, 0, 1. Yeah, -1 to first, -1 to -1. Is there any -1 to 1? No, -1 to -1. Next, -1 to 0, already given, first element. Next, -1 to +1. Next, you can start with 0, 0 to -1. 0, comma -1 not given. Then 0 to 0, 0, comma 0 not given. like 0 to 1. I think 0 to 1 already given. Like finally, 1 to minus 1. No, not given. 1 to 0, not given. 1 to 0 given. No, 1 comma 1, not given. Is it right, student? Have written?
Yes, sir.
That's it, simple. So if you draw the like arrow diagram, it will becomes easy to write remaining. You cannot confuse it. Like 2, 3, 4, 5, 6, 7, 8, 9. Any doubt?
No, sir.
This is important. Enough number of elements they given in that you have to write like this. You will get enough value 3. Those 3 elements we should write first. Then after we have to write all the possible order pairs. In that already 2 is given. With the help of this given 2 order pairs alone, you can find the 3 elements of A. 1, 0, minus 1, 0, 1. That's it. Okay, so the first exercise completely which belongs to the Cartesian product we completed. See here, next concept alone relations. Relation. Okay. So general relation they given here consider. So all of you, everyone, not only these relations and functions, you can once you can go through each and you can read each and every line of sets, relations and functions, even next chapters also, because they given different example to understand very briefly. Okay. They have taken here 3 different. So this is P is a domain. What are the elements which is belongs to domain A, B, C? So clearly here, what is the codomain and what is the range?
Range is those that are getting related, and codomain is the complete thing in B, in Q.
Yeah. See here, Ali, Banu,
Except Chandra,
given
we should.
Chandra. So this is range. So including all the elements. So the set Q is the codomain. In that, how to write, you know, what if I take the relation, for example, capital R. R of P. R of P means the set of all images is give the range. So what is the images? A image is Ali. B image is Banu as well as Binoy. So in the same way, like whatever the images are there, Ali, Banu, this Chandra alone range. Divya has no pre-image. It's not related to any element. So that just it belongs to codomain. Codomain means consider all the elements, but range means just images. Right, let's see now. I'm going to take a relation from A to B here. This is B. Okay, I'm taking this is capital A, this is capital B, capital R is relations from here. I'm going to take here A, B, C. Here I'm going to take here some X, Y, Z, W, some Q. Okay. I'm going to mapping from A to B. A is mapping to X. B is mapping to Y. A is mapping to again Y. D is mapping to W. Now any bar, this is a relation from A to B. What is the domain of the given relation? What are the elements? Domain.
ABCD.
Yeah, domain is clearly A, B, C, D. Fine. Range of given relation R
YXW. Double, yes sir.
X, Y, W. Am I right? What is codomain of relation?
XYZWQ.
Codomain of given relation is all the elements. Codomain is always all the elements. Clear? Fine. So here now different types of function. I said that a function is a special case of the relation. Okay, this is relation.
Sir, I
Is
have a
this
doubt, sir.
yeah?
So when D is not related with W and where D is isolated, then what is the name for when we actually take in the whole set of A? Like we call all the elements in B as codomain, and in the case of the set A, sir.
Once again, can you repeat again?
So when D is not related with W,
Okay, D is not related W. Okay.
yes, sir. In that sense, we actually call the domain of the relation to be A, B, and C. And when we
Oh.
include D, is there any special name for that?
D is not related to W. You are saying.
Yes, sir.
So in that case, what is the domain?
Domain will be A, B, and C.
So actually, in relation, so here they're taking the relation nothing but D must have some related to any one of the element, must be, because
That is all the elements of A has to be related, sir.
yeah, sure, surely.
Okay, sir.
Okay, what about other student? His
Yes.
question, his doubt is, so is it necessary that each and every element of A should have image in image to B? Is it compulsory? If D does not have any relation, can we say that the domain is ABC alone? No. Domain is unique. Range codomain is different. So here relation means each and every element of A must be have some relation to the element of B. So in the B, some elements may not be having pre-images. Here what we called actually, yeah, here, yeah. Look at here. What about here? A is related to X. Here X is called image of A. X is called image of A, then A is called pre-image of X. You have to remember all this. So what about Y? Y is the image of B with respect to R. Here B is the pre-image of Y with respect to the given relation. Then in the same way, Y again the image of C. C is the pre-image of Y. Now coming to Z, for Z, is there any pre-image? W, is there any pre-image?
No, sir.
Q, is there any pre-image? No. So here D must be have some relation to the any element, not only W, you can take like a D. Now here see here, first the function. Now function concept is same like here. Function is a special case of relation. Function also each and every element of A should have image. But the condition is what? See, can I say that if I take the here D to Q, is it relation? Yes, it is a relation. It is a relation. But it is not a function. It is a relation, I'm saying, but it is not a function, because function in the sense every element should have unique image. Unique image. What about D? If you see D
Sir,
here,
it is having two images, sir.
yes, exactly. So it is not a function. But if I take here, like here, okay, I'm taking like this. Now, is it function? Yes, it is a function. It is a function. You may get doubts, sir, here why having two pre-images? Function in the sense every element of A should have a unique image. That only you have to remember. Unique image. Okay, what about A having how many images here? A having, B having, yes,
Two.
two images are B.
No, sir, one, sir.
Yeah, C,
That is also only one, sir.
D, one images. Now it is a function. Now it is a function. But okay, right. If I take like, okay, I'm going to take a different this. Um, Look at here. I'm going to explain the function concept also here. It is very, very easy. Okay, this is A. This is B. 1, 2, 3, X, Y, Z. Now, 1 related to X, 2 related to X, 3 related to X. What about this? Is it function? It is a relation because every element having image. So is it function?
Yes, sir.
One having how many images? Only one. Two.
One.
The meaning is, simply remember, the function is I'm giving best idea to check whether it is function or not. Just to remember that. So here, for example, you are the student.
Father
So,
and son.
uh, yeah, that like student wise, I'm giving. See, now mathematics class will start, like there are the students are there which is belongs to C section. C section is there, B1, B2 sections are there, ABC section, 3 sections are there. There is a student, one student is there. The one student can go to 3 classroom at a time. At
No,
a
sir,
time.
he is having only one body, sir.
Yeah, he can go to any one of the classroom, either C, B1, C, A, B, C, any one of the section at a time. Okay. So, but that is the only way he can go to, the student can go to a classroom or a single classroom at a time, but one student cannot go to two or more classes at a time. It is not possible. But see here, three students are there. They want to go to a single class. Let us take here A, B, C, D are the student, X, Y, Z, W, Q are the classrooms. See here, A student can go to X classroom, B and C student go to Y classroom Y, and D student can go to classroom W. But is it possible to go one student? If I take the mapping like A to Y, A to X, A to Y, is it possible? The student
Sir.
A can go to both classrooms.
No, sir.
No, it is not possible. So that is not a function. But see here in the below example, I have taken A having 1, 2, 3. The students are 1, 2, 3. Classrooms of X, Y, Z. Is it possible? 3 students can go to classroom X. Is it possible?
Yes, sir.
Yeah, function. Function.
Sir, we
Like
can
that.
take B as father and A as son, no, sir.
Yeah. Correct example. There are some children are there, fathers are there. So 1, 2, 3. Okay, you can take B as father, but these three children belongs to this father. Okay, right. Fine, students. I hope that you understood just what is mean by relation, what is the mean by function. Relation we can take like even uh, B is mapping to Z, C is mapping to Q. We can take many ways. This is also a relation, but is it function? No, not a function. It is relation, just relation, but it is not function.
Sir, we can say that all functions are relations, but not all relations are functions.
Exactly, exactly. That is the reason function is a special case of relation, but every function is not a. Every function is a relation, but every relation is not a function. Correct. Understood? Every function is always a relation, but every relation is not always function. Simple. Okay, in functions, types of functions will be there like one function, onto function, bisective function, inverse function, composite functions. This we will discuss. Actually, this is belongs to class 12. Anyhow, we'll discuss in class 11th also. But you have to uh, uh, it is here the thing is the important functions are like types like identity function, constant function, modulus, absolute functions, greatest integer function, signal functions, logarithmic function, exponential function, trigonometric functions, inverse trigonometric functions, so hyperbolic functions. Like types of functions are important. You have to remember each and every function, especially domain and range and codomain. Okay, for example, logarithmic. We know that log x. What is the graphical representation of log x? What is the domain of log x? So domain means whatever the value we are giving input values, input. That is domain. Input is independent, but output is dependent. Whatever the output we are getting, the output is called the range. We are giving some input. For example, I am defined a relation from natural number to integer. Here natural number is the domain. N to R from N to R. N is a natural number. R is output, that is a real number. Okay. Till what time the class? 2. I think 3:10. Am I right?
Yes, sir.
Okay, a simple example I'm going to give for that relation. Now I'm giving some example. You only tell me what is the domain, what is the codomain, and what is the range. I defined the relation here from capital into R. Capital into R. I'm taking like F or some R1. You can your wish. Okay. R1. R1 is a relation from N to R. R1 is to from N to R. Okay, fine. I'm taking this R1 condition. I'm giving the relation by satisfying this condition, x square. Okay, I defined here R1 of x value is x square. See here, always remember that. So whatever we are giving the input, whatever the input we are giving, that you can take as x. Whatever we are getting the output, that will give f of x. F of x nothing like y. So x's belongs to n. Then output f of x means y. Y is belongs to r. Okay, I have taken x square. What is the set of all natural number 1, 2, 3, so on. Am I right? Up to infinite. So what are the output? I'm giving input is natural number. Output, substitute here in place of x.
So
Substitute
1, 4, 9, 16,
1, 1, 4, 9, so on. So actually real number nothing but real numbers are 1, 2, 3, 4, 5, 6, 7 like that. All are real number, but according to the mapping, According to this defined function, so 1 is mapping to 1 alone, 2 is mapping to 4, and 3 is mapping to 9, 4 is mapping to 16, so on. Can you tell me what is the domain of R1? Domain of
All
R1 is
natural numbers.
all natural numbers. But range of R1, this is important. Yeah, range of natural numbers are what?
X square such that X is a natural number.
No, simply you can write that roster form you can write.
1 to 4.
1, 4, 9, 16, so on. Am I right? This is the range. Then codomain means
Real numbers.
real number. Do you understand the what is the range, the difference between codomain with? According to here, I am taking x square. Okay. Then if I take x cube, what is the range we are going to get? X cube.
1, 8, 27, 60.
64.
Right. That is the range. Remain total, including all the elements. Simply here, when they define here, simply here itself, we can say this is always, sorry, this is always, remember that domain. This is codomain. According to the mapping, we are going to get some output. Your output 149. That all outputs is given by range. Range, domain of the relation, domain of the function, domain of the codomain of the relation, codomain of the function, right? Range of the relation, range of everything will be same. Just a function is the special case of. Okay. So next class we will discuss. We'll discuss the second exercise. Second exercise, if possible, you can try yourself. You can try yourself because here one example I'll explain first. They given. See, whenever you want to find the domain, codomain, and range, remember one important point that you should write the given relation in roster form. They given the set builder form. Some statement is given here. X comma y such that 3. Statement is given. Okay. So they define the relation here from where to where? A to A. They define the relation from A to A. See, R is relation from A to A. How they define here? 3x minus y is equal to 0, or else it can be written as y is equal to 3x. Y is equal to 3x. Can you able to write that set builder form into roster form? Can you tell me what are the order pairs we are going to get here? When I substitute x is equal to 1 here, x is equal to 1. What is the?
Sir, 3, 6, 9 and 12 will be the elements, sir.
No. We have to write in order pair. If I take x as 1, y as 3, am I right? If I give input is 1, these are the x values. Substitute all x values here.
2 comma 6.
2 comma 6. Then
3 comma 9.
3, 9, 4.
3 comma 9, 4 comma 12.
That's all, sir.
That's all. Why don't we take like 5 comma
Because the
15?
final term is 14.
Exactly. See here, you should
Sir, and
not.
as a condition, the 3x minus y equal to.
Yeah, the thing is, when we take 5 comma 5, okay, 5 is belongs to A. First set 5 is belongs to. Is here 15 belongs to set A? No. So this is absolutely right, correct order. So give this x values 1, 2, 3, 4. We are going to get output. Even output also which is belongs to A and because input whatever we are giving input that is belongs to A. Output also which is belongs to A. It should not cross 14. Fine. In that, can you tell me what is the domain?
1, 2, 3, and 4.
Especially whatever the defined, this is special relation. We are not writing Cartesian product. Cartesian product means it has 14 into 14. This many order pairs we get. Here in this, the domain of R is in this relation 1, 2, 3, 4. That's it. Then, what is codomain here?
The numbers from 1 to 14.
1 to 14. That is A. Very good. Codomain is fully. But you may get doubts, sir. Sir, you said that previously, like We can consider domain as set of all elements, not like that. According to what are the elements it is taking, right? What about your 1, 2,
3, 6, 9, 12.
Yeah, range is clearly 3, 6, 9, 12. That is range. These are the output. That's it. Like that, you can try the remaining all are very easy. They ask set builder form, roster form. Set builder form. What is roster form? 5, 3, 6, 4, 7, 5. Yeah, we return roster form clearly. Set builder form means we can write the state.
Sorry, x is equal to y minus 2.
Simple, right? Telling questions are very easy, right?